All right, here are the notes for 1.4, day 2. But before we get into it, I wanted to touch upon a few things from the first part, okay, when you looked over the notes. So this idea of congruency, all right, congruent angles is actually a really big idea in geometry. Okay, angles with the same measure are congruent angles. That's different from equal angles, okay? And so I know it's a little bit hard to see here in the copy version, okay? When we talk about measures, okay, that's what the little m stands for, the measure of angle A and the measure of angle B. So if you can measure it, right? When we talk about the measure of an angle, then we use equal, okay? I'm gonna find my ink here. We use equal, right? When we talk about the measurement. But if we're just talking about the angles in general, all right? Like let's say we don't know what the actual measure is, right? Like we don't have a protractor, but you can clearly see that they're the same, okay? Then we say that these angles are congruent, okay? I'm going to rewrite this here because it got cut off here. But angle A is congruent to angle B, okay? So it's an equal sign with a little curve on top. That's what congruent means, all right? We don't use the little m in front when we talk about measures with congruency. We use the equal sign when we talk about the measures. And when we're just talking about generalities, okay, we use the congruent symbol. So here in example 3, all right, this was in the notes. Um, Angle MIG, right, MIG right here. You see how it has the triple arcs, the 3 arcs, right? And notice over here, across from it, it also has 3 arcs. That means they're the same measure. Okay. Now, again, we don't know exactly what the measure is, but we know that they are congruent. They're the same. So therefore, we say they are congruent. If you want to say they have the same measure, then what you would write is the measure of angle MIG is equal to the measure of angle JIH. Okay, so just wanted to clarify that difference, right? And so here in parts C and D, again, because we're talking about the measures, that's why we use the equal sign, all right? Just wanted to do a quick review. Here's some proof that we do algebra work a lot in geometry, okay? If angle ROT, so if this whole thing together, if these two angles added up, that's why it's a plus sign here, right? If you add it up, it equals 155, and so, we just wanted to make sure that you are using your solving skills. Okay. All right. Um, so for part 2 or day 2 of 1.4, I'm gonna go through a mixture of just copying some stuff from the solution notes, and then also going over some stuff together with you. One thing I want to mention is like looking actually in both C and D, right? Like where do they come up with this 30, right? Um, the angle measure between each number is 30 degrees because obviously a clock is 12 hours, right? And so if you remember, a circle is 360 degrees, and 360 degrees divided by 12 of these, right, is 30 degrees. So between each number is 30 degrees, all right? And so like here in part C, when we do 305, right? So we know that the minute hand is here at the 1, and the hour hand is a little past 3, but um, we have 1 and 2. That's going to be 60 degrees so far. And then you have a little bit here that went past the 3, right? Well, that's 5 minutes out of 60 minutes, right? That's 5/60th. Okay, hopefully you can hear that clearly. 5/60th, but times 30 degrees between 3 and 4, right? So that's 5/60th of 30 degrees, and so that's how we got 2.5 here. And so 30 plus 30 plus 2.5. Over here for 440, right? Um, Between these two hands of the clock, you have between 5 to 8, right? 30 degrees, 30 degrees, 30 degrees, but you also have this little gap right here, right? And so from 4 to 5, right? Well, we got to figure out how much did it go, okay? It went 20 of 20/60ths times 30 degrees, all right? That gives us the 10, right? So 30 plus 30 plus 30 plus 10 gives us 100 degrees, okay? All right, so I wanted to go over a couple things here, all right, because we briefly touched upon this in algebra, okay? When we talk about probability, remember probability means the number of outcomes you want over the total outcomes there are, okay? Um, so for part A, it says if one of the 4 points is picked at random, what's the probability that the point lies on the angle, okay? What's the probability that the point lies on the angle? Well, all 4 of those points are on the angle, right? And so the probability would be there are 4 total outcomes, right? Because there are 4 points, and the outcome that we want for that lie on the angle, that's 4 also. And so when it's 1, it actually means it's 100%, right? It's going to happen for sure. Okay. For part B, it says if 2 of the 4 points are selected at random, what's the probability that both lie on CA? Okay. So here are all of the combinations of 2 points, right? I wrote it here for you, okay? But it says if 2 of the points are selected at random, what is the probability that both lie on CA? Okay, so on CA. And so I think there's 3 of those, right? AB, right? AC, okay? And BC. So the probability that 2 points lie on the ray CA is going to be, there's 3 of those outcomes that we want out of a total of 6 possibilities, right? 6 total outcomes, okay? Which of course is 1/2, all right? Part C says if 3 of the 4 points are selected in a random order, what is the probability that the ordered letters will correctly name the angle shown, right? Correctly name the angle shown. All right, so here's the list of all of the combinations of 3 of the 4 points, right? And so the circled ones are the ones that are correct, right? That's how you can correctly name that angle. So here the probability, right, is going to be, there are 24 possibilities, 24 possible outcomes, I believe, and only 4 would be the correct way, right? And so this simplifies to 1/6. All right, so in this last example, all right, you're given 5 angles, okay, with measurements given to you. Part A says if one of the 5 angles is selected at random, what's the probability that the angle is acute, right? Remember, acute means angle is less than 90 degrees, okay? So probability that the angle is acute, okay? So there are 5 angles, right? 5 of those. And how many of those are acute? We have 50, 60, and 40. That's 3 of those, right? So 3/5, okay? Part B says if 2 of the angles are selected at random, what's the probability that here's the list of combinations of 2 of these angles, all right? And there's 10 of those, I believe. And then 3 of them are the ones where they are both acute, all right? So the probability here where they are both acute, okay, is 3 out of 10, all right? And generally for probability, we're going to leave it as fractions, okay? So that's that, all right? That's 1.4, day 2.